Hello everyone. In this video, you will be learning about chapter 7.3 of A Math, which is on the topic of midpoint of a line segment. In this video, you will be learning how to find the midpoint of a line segment. But before we can know how to find the midpoint of a line segment, we may need to first know what exactly is a midpoint. So for a start, we need to first know what is a midpoint. The definition of a midpoint is that it is a point on the line segment that divides the line segment into two equal parts. So as a visual representation, I have this line segment over here for which the endpoints of this line segment are A and B. The midpoint is actually right in the center of this line such that it divides the line segment into two equal parts. So we see over here that AM is actually equals to MB. Right, so the lengths are actually equal on both sides of M. So how do we then find out the coordinates of M? And that is what we're interested in this topic itself. So let's say in the aspect of coordinate geometry, I have the coordinates of A, which I let it be x1 and y1. And if I have the coordinates of B as well, and I'll let it be x2, y2, then my coordinates of M will go by this formula over here, x1 plus x2 divided by 2, which is its x coordinate, and for its y coordinate, it will be y1 plus y2 divided by 2. If you're wondering why is it that this is the formula for finding out the coordinates of the midpoint, think about it as an average. Okay, we understand that M is actually the middle, the midpoint, so we're taking the average of the two x coordinates as well as the average of the two y coordinates. So because we're trying to find the middle, linking it to average, therefore this will be how we calculate the coordinates of the midpoint. We will then look at the example to see how we can apply this formula itself. We will begin by taking a look at this example over here. So in try 7, which is found in your textbook page 171, we are given a diagram that shows a triangle ABC with vertices A, B, and C, whereby the coordinates of A is 4, 2, B is 1, 5, and the coordinates of C is 5, 6. They are all shown on the diagram. The question also says that the points X, Y, and Z are the midpoints of the line segments AB, BC, and AC respectively. So we see over here that X is actually the midpoint of the line segment AB, Y is over here, which is the midpoint of the line segment BC, likewise for Z being the midpoint of the line segment AC itself. In part I, we want to find the coordinates of X, Y, and Z. So we need to individually find out the coordinates. So let's begin with looking for the coordinates of X. Because X is actually the midpoint of AB, we then make use of the coordinates of A and the coordinates of B. By applying the formula that we have just learned, that is the x coordinate of X will be the average of the X coordinates and the average of the Y coordinates. So in other words, okay, we will have 1 plus 4 divided by 2 to achieve the X coordinate of X, and taking 5 plus 2 divided by 2 to get the Y coordinate of X. So doing this calculation in our calculator individually, we will get our answer to become 2.5, 3.5, and that will be our coordinates of X. You may wish to pause the video over here to give this question a try to see if you can apply the formula successfully to find out the coordinates of Y and Z. So I hope that you have given it a try. To find out the coordinates of Y, we will take the coordinates of B and C because Y is the midpoint of BC. So the x coordinate of Y itself will be 1 plus 5 divided by 2 as shown here. And then the Y coordinates will be 5 plus 6 divided by 2. And that simplifies to give us 3, 5.5. And therefore that will also be the coordinates of Y. Lastly, the coordinates of Z would then be found by taking 5 plus 4 divided by 2, and also 6 plus 2 divided by 2. And that will simplify to become 4.5 and 4, or of course you can write it as 4.5 and 4. and therefore we get the exact coordinates to be 4.5 and 4. I hope you're successful in applying the formula. We will now take a look at part 2. So in part 2, it says show that AC is equals to 2xy. What does this actually mean? AC itself, when written like that, okay, with capital letters, we are actually referring to the length of the line segment. I hope you recall that from your E-Maths chapter 4. So what we want to show in part 2 is to find out how is it that the length of the line segment AC is eventually equals to 2 times the length of the line segment XY. So in case you have forgotten the formula for the length of line segment that is found in your E-Maths, we recall that given the coordinates of A and B, I can apply my formula of square root of x1 minus x2 square plus y1 minus y2 square. Okay, so therefore, to find out the length of AC by applying this formula, we will make use of the coordinates of A as well as the coordinates of C. Okay, for which I have placed over here the coordinates of x, y, and z as well already, which we found in part I. So AC would be found by applying our length of line segment formula to be as such. Because we're trying to show something, I would like to encourage you to actually write it in exact rather than to press into calculator. Because when you press into calculator, you will end up doing an approximation or rounding off that may not be sufficient when we're trying to show or prove a certain thing. So we should get the answer of square root 17 instead. Whenever possible, we also want to learn how to simplify the cert. Okay, we may do that in part 3. So now that I have already found AC, I need to then now find out what is xy. We don't try to find out what is 2xy first, so let's do things one step at a time. So to find out the length of line segment xy, using the same formula, I will be able to do this calculation, for which I will be able to get a value of square root 17 over 4. As I said earlier, wherever possible, we try to simplify the cert. We know that 4 is actually a perfect square, for which we can take square root of 4 at the denominator, and that will allow us to get a simplified fraction of square root 17 over 2, or rather a simplified cert. So now that we have found out the value of AC as well as the value of xy, we want to show that AC is equals to 2xy. So AC being equals to square root 17 is actually 2 times of square root 17 over 2, which we can see over here. Okay, and therefore, since square root 17 over 2 is none other than xy, we can now say that AC is equals to 2xy. So this will be how we go about showing our answer for part 2. Next, we take a look at part 3. In part 3, the question is asking whether AB is equals to 2yz and whether BC is equals to 2xz. I hope you find this structure of the questions familiar, because we just did something similar in part 2. Okay, so the process that we are going to take is actually the same. You may wish to pause the video over here to give this a try. So to first verify AB is equals to 2yz, we will actually individually find out what is the value of the line segment AB, which gives us square root 18, which we know that 18 is actually 9 times 2. So therefore, in simplifying this cert, it will give us 3 square root 2. Then for the length of the line segment YZ, also using our length of line segment formula, I will be able to perform this calculation, and that simplifies to be square root 9 over 2. And we know that square root 9 is actually 3, so I can say that it is 3 square root 2, for which I need to rationalize it so that it will facilitate us being able to prove this statement, and that will allow us to get 3 square root 2 over 2. So now we can see very clearly, based on what we have arrived at for AB as well as YZ, that when I multiply YZ by 2, I am going to get AB itself. So therefore, we say AB is equals to 2 times 3 root 2 over 2, which is equals to 2 times of YZ. and that will be how we show the first question in part 3. Then the same applies to the next question, which is BC is equals to 2 exact. So same thing, finding out the length of the line segment BC, which is going to be equals to square root 17, and then finding out the length of the line segment XZ, which is going to be equals to square root 17 over 4, for which we can simplify this to give us square root 17 over 2, and hence we see that BC is 2 times of XZ, and that will be how we go about showing the second question to part 3. Okay, so we see that in try 7, it isn't so much of focus on the midpoint. The midpoint focus was more on in part I. Okay, then later on it was writing on the coordinates that we have already found in part I for our calculations in part 2 and 3. We will now move on to more examples to see how we can apply our concept of midpoint of a line segment. We now take a look at try 8, which is found in your textbook page 172. So in part I, we see that the question says the line y equals to x plus 1 intersects the curve y equals to x squared plus 2x minus 1 at the points A and B. We want to find the coordinates of M, which is the midpoint of AB. While this question seems to be very short with only 2 sentences, it actually has a lot of things found within it. As I mentioned right at the start of this chapter, we need to be able to unpack all the information out of a question, and it is very helpful for us to draw a diagram. So we will start by understanding the question, okay, and that would be by drawing a diagram first. So in this question, it talks about a curve and a line. So let's start off with the curve. This is actually a quadratic curve. Furthermore, the coefficient of x squared is positive 1. Therefore, it is a happy face or a U-shaped curve. So we draw a U-shaped curve. Okay, so we try our best to draw something that is as accurate as possible, okay, while it need not be drawn to scale. Alright, then there is also a line which intersects this curve. So this line is y equals to x plus 1. And the coefficient of x tells us the gradient of this line, and since the coefficient is actually positive 1, it means that it is an upward sloping line, hence we can draw something like that. Okay, so this is just a rough sketch. It need not have the axis itself, we're just trying to understand the problem. So in this question, it says that the intersection is at the points A and B. So I'm going to indicate the intersection. It really doesn't matter which one is A, which one is B, because they are just arbitrary references. Okay, we need not be too particular about which one is to be A and which one is to be B. So I'm going to indicate the one on the left as A, and then the point on the right to be B. Okay, so in this diagram, I have actually interpreted the first sentence already. We now take a look at the second sentence, which is actually the question. It wants us to find the coordinates of M, which is the midpoint of AB. So if I know the point AB already, this line segment over here, okay, which I have just indicated in purple, okay, will be the line segment AB, and we are taking the midpoint of this line segment, so I've just indicated with a cross here. That will be where M is actually going to be. That is supposed to be the midpoint. Okay, so I have kind of completed the diagram to help us understand the problem. So we now want to find the coordinates of M. Okay, while we are able to draw the diagram, you must of course be able to make the diagram be helpful for you. Alright, no point drawing a very nice one when you are not able to make use of it. So knowing that M is actually at this position, and knowing that the formula for finding out the midpoint requires us to know what are the coordinates of A and B, okay, that will mean that our first question that I would naturally think about after drawing the diagram is, what do I need to find first so that I can get the coordinates of M? So that actually led me to what I mentioned just now. I need to use the formula, and for me to use the formula, I must know the coordinates of A and B. So with this question in mind, it helped me to devise my plan, okay, which is to first find the coordinates of A and B, for which I would then ask myself, how do I do that? Okay, so in order to do that, since we recognize that A and B are actually the intersection points of your curve as well as your line, we know that when there are intersections between a curve and a line or anything, okay, any graph at all, we are looking at solving the equations of the curve and the line simultaneously. So we have the graphical representation by observing the intersection points, and then the equivalent algebraic representation is that we are taking the equations and solving them simultaneously. So to find the coordinates of A and B, I am going to solve the pair of simultaneous equations. And therefore, my plan itself will first be solving the pair of simultaneous equations to find the coordinates of A and B. And then I can use my midpoint formula to find our coordinates of M. Alright, so you may find over here a very elaborate planning process. Okay, this is really more for the start whenever you encounter a coordinate geometry question. Once you get a hang of it, you will find that this process becomes so natural for you, you don't really have to write it out. Okay, however, I am a strong advocate for us to draw a diagram. Okay, so when it comes to coordinate geometry, we really got to draw a diagram to illustrate the problem, to help us, let it guide us in terms of our planning process and also our whole working. So with this plan, I'm going to go into a next slide so that I have space to write. So I'm going to put my plan over here. So my first thing that I need to do is to solve the pair of simultaneous equation, right? So therefore, I will indicate my first equation and my second equation in this manner, and I do my substitution of 1 into 2, for which I get x plus 1 equals to x squared plus 2x minus 1. I hope that we know how to solve this algebraically. I decided to bring my x plus 1 over to the right as such, and then I'm going to be getting a quadratic equation eventually. So with my quadratic equation of x squared plus x minus 2 equals to 0, coincidentally, I can factorize this, so you may use your quadratic formula or by doing your cross method. I decided to do by factorization, okay, which is my cross method, and I will get x plus 2 times x minus 1 equals to 0. Right? I'm not going to show the cross method, as I mentioned many times in class, because I believe that you are fully capable of doing that on your own already. So with x plus 2 times x minus 1 equals to 0, we can say that x plus 2 is equals to 0. Otherwise, x minus 1 is equals to 0 as well. Therefore, that will help us arrive at the solution of x equals to negative 2 or x equals to 1. We should not forget what we were trying to do in the first place. We were trying to find out the coordinates of A and B. So this is only the x coordinate. So when x is equals to negative 2, I can find the corresponding y value by substituting into one of these equations here, and I will get negative 1. I substituted back into equation 1 because it's much easier. And then I will say that one of the coordinates, okay, will be negative 2, negative 1. As I mentioned, it doesn't matter which one is A, which one is B. They are just arbitrary. So next, I will then substitute x equals to 1 into my first equation, and I get y to be equals to 2. And therefore, my other coordinate will be 1, 2. So I have actually already done step 1. I have solved the simultaneous equation, and I have found my coordinates of A and B. So the reason for me to find the coordinates of A and B was for us to find the coordinates of M by using our midpoint formula. Okay, so using our midpoint formula, alright, I will be able to get coordinates of M are taking negative 2 plus 1 divided by 2, and negative 1 plus 2 divided by 2 for its y coordinates. And that simplifies for us to be negative half and half. So our coordinates of M would be as such. Alright, I hope you are able to follow my train of thoughts in solving this question and how I actually come up with this plan and executed the plan to solving the question. We now take a look at part 2. So in part 2, it says that D is actually the point 20 such that it is the midpoint of CM. Find the coordinates of C. So part 2 is a continuation of part I. So I will make use of the diagram that I have already drawn in part I. That will be my process in understanding the problem first. So this was what I had in part I. Okay. Now we see that D is actually a point. Like I mentioned, sometimes we may not need to draw in for exact. Okay, I just need a reference diagram. So D is going to be maybe a point outside of the curve and the line. Okay, since there is no mention that it is found on the curve or the line itself. And we know that D is actually the midpoint of CM. So there's another point C. Alright, M is over here. So to draw my diagram, I have decided to have it drawn in this manner, to have my C outside here and my D being the midpoint of CM. Alright, so how can I find the coordinates of C? That is what we're trying to do. So we know the coordinates of M already, and we know the coordinates of D. And D is given to be the midpoint. Okay, so the question, as I mentioned a few times already, is how could we achieve the coordinates of C? Right, so I'm just rephrasing the question over here. So to come up with the plan that we have, we will be letting C be a set of unknown coordinates, for example, because I need to use the midpoint formula, or I want to use the midpoint formula. Okay, but I'm going to use the midpoint formula in a reverse process because I now already have the midpoint. I just do not know what are the coordinates of C. So my plan is, let C be a set of unknown coordinates and use the midpoint formula to work in reverse. Alright, so with this plan, how would that be? I will let coordinates of C be A, B. Okay, then using my midpoint formula, it will mean that A plus negative 0.5 divided by 2, comma B plus 0.5 over 2 is equals to 2, 0. So where does this come about? Remember, D is actually the midpoint, so these are the coordinates of D. And then negative 0.5 and 0.5 over here, they are my coordinates of M. So in case you have forgotten, going back to the diagram, okay, D is 2, 0, M is the answer found in part I. Okay, so the coordinates of C with the coordinates of M will give us the coordinates of D. And that explains why I have this. So since they are equal, that means the x coordinate must be equal to the x coordinate here, and the y coordinate must be equal to the y coordinate over here. And therefore, I can say A minus 0.5 over 2 is equals to 2. Likewise, B plus 0.5 over 2 is equals to 0. So I will now see A minus 0.5 is equals to 4, and hence A is equals to 4.5. And in solving my other equation over here, I will say that B plus 0.5 is equals to 0, and hence B is negative 0.5. And therefore, I can say that C has the coordinates 4.5 and negative 0.5. I hope you are able to understand what I did to go through, what I did in order to find out the coordinates of C for part 2. Okay, and again, it relied on my strong understanding of the question, which I depended on drawing a diagram. So I hope that at this point you are already familiar with finding out the midpoint of a line segment by using the formula. We now take a look at try 9, which is the last question that I would like to cover in this video. It is found on your textbook, page 173. It says that the diagram shows a triangle with vertices A, B, and C, for which the coordinates are given and also shown in the diagram. M and P are midpoints of AB and AC respectively. So we're talking about M here and P over here. Okay, the line that is passing through M and P meets the x-axis at point Q. So if I have a line, it must be a straight line because I mentioned a few times that all lines are straight. So this line over here that passes through M and P, it meets the x-axis at this point Q. We want to find the coordinates of M and P. Okay, and then later on in part 2, we want to find the ratio of MP is to PQ. So let's start off by answering part I. How do we find the coordinates of M and P? M being the midpoint of AB, we have the coordinates of A, we also have the coordinates of B. P being the midpoint of AC, we have the coordinates of A, we also have the coordinates of C. So I hope that we are able to see we have all the necessary information to apply our midpoint formula to help us find the coordinates of M and P. So you may wish to pause the video over here to try to do your own calculation to find out what are the coordinates of M and P. So in solving part I, okay, let's check our answers. M would be 6 plus -2, so taking the x coordinates, adding them up, divide by 2, and the y coordinate will be 9 plus 3 divided by 2, and that simplifies to 2, 6. To get the coordinate of P, I will have 6 plus 4 over 2, comma 9 plus -5 over 2, and our coordinates of P will be 5, 2. I hope that you're successful in achieving this answer. Next, we will take a look at part 2, which is slightly more challenging. Okay, so if we were to look at just the question itself, asking us to find the ratio of MP is to PQ, I wonder what is the thinking that you have behind this question? What impression do you get out of the question asking you to find the ratio of MP is to PQ? I believe the majority might be thinking that we need to find out. Okay, so this was what I just mentioned. Okay, so most of you might be thinking that we need to find out the length of MP, likewise the length of PQ, because otherwise how else would you find the ratio, right? I need the quantity MP and I also need the quantity PQ. So to find the length of MP, okay, that will mean that if I have the coordinates of M and P, I can use the length of line segment formula to find the length of MP. And that is a problem. That is not a problem, okay, because part I already found the coordinates of M and P. What about PQ? If I want to find the length of PQ, I have the coordinates of P, but do I have the coordinates of Q? So to find the length of PQ, I need to know what are the coordinates of Q. Okay, so if this is the direction that we're heading to, let's further explore how do we find the coordinates of Q. Okay, so in order to find the coordinates of Q, firstly, where is Q? Q is on the x-axis, and being on the x-axis, we know that the y coordinate will be equals to 0. So if I know that y coordinate will be 0, then the next question would be, how do I find the x coordinate of Q? As mentioned earlier in the question, we know that MPQ is actually a straight line. So if I know the equation of MP, it is going to be the same equation for MQ. Hence, if I were to be able to find the equation of the line MP, then I can substitute y to be equals to 0, and I can find the coordinates of Q. And hence, to devise the plan, this would mean that I need to know what is the equation of line MP that will help us to find out the point Q. Alright, sorry, my animation is taking a little bit of time. Okay, then after finding the coordinates of Q, since I already have the coordinates of M and P as per our earlier objective, which is to find the length of MP and PQ, this will be sufficient for us to then determine the ratio MP to PQ already. So it seems like it's quite an elaborate plan. Okay, plan. So let's try it out. Alright, so firstly, to find the equation of the line MP, I need to know the gradient of the line MP. I have the coordinates of MP over here, which is found in part I already. So the gradient would actually be 6 minus 2 over 2 minus 5, which is 4 over negative 3. So the equation of MP will actually be y minus over 2 equals to negative 4 over 3 times x minus 5. Okay, and this will simplify to this. I brought the negative over after doing the expansion. And hence my equation of MP would be y equals to negative 4 over 3x plus 8 and 2/3. In case you find this unfamiliar, I have just covered it in our most recent coordinate geometry lesson. I have introduced to use this other formula of y minus y1 equals to m times x minus x1, whereby x1 and y1, they are coordinates of a given point of the line that we're discussing. Okay, in this case it will be MP and Q. And I have decided in this particular case that my x1 and y1, I use the coordinates of P, which is 5, 2. You may definitely use the coordinates of M as well, because you're finding the equation of MP. It doesn't matter whether you're using the coordinates of M or the coordinates of P. Okay, so I have found the equation of MP already. By the way, if you want to do it the eMath way that I have done previously in chapter 4 of eMaths, by all means go ahead. There is no restriction or limitation. But I hope that over time you notice that this method, the way that I've done it, is somewhat shorter in the working itself. Okay. So I have now found the equation of the line MP already. So a second step of our plan was to find the coordinates of Q. So when y is equals to 0, because Q is on the x-axis, we substitute 0 into our equation of the line MP, and that would give us 4 over 3 is equals to 8 and 2 over 3. Hence x would then be equals to 6.5. And therefore my coordinates of Q will be 6.5 and 0. So that is our second step done. Now we have to address the last step, which is to find the length of MP and PQ. So the length of MP, okay, since I have the coordinates of M and P, using my length of line segment formula, I will be able to get this. Okay, and that is equals to square root 25, which is 5 units. We do the same to find the length of PQ by applying our formula, and we will get square root 6.25, which simplifies to 2.5 units. So I have found the length of MP and also the length of PQ. So the ratio of MP to PQ will be none other than 5 is to 2.5. But I hope that you are aware that ratios quantity cannot be decimal places, so we need to simplify this. Either you make use of your calculator to help you simplify by pressing into a fraction, 5 divided by 2.5, and then you will get a simplified form, since ratio representations are equivalent to fractional representations. Otherwise, you can do it like what we did in primary school, multiply by 10 to get rid of the decimal, then dividing by 25 across to get 2:1. So this is what we have as our answer to part 2. And while this plan seems fairly short because it is just 3 steps, but you know that the working was fairly long. Okay, we went through multiple slides to arrive at this answer. So sometimes I like to challenge ourselves to think of whether is there an easier way to solve this question. I'm not sure whether you read your textbook, okay, the parallel example for try 9, but maybe if you have not, okay, there is actually a simpler way to solve this question, and that relies on our concept of similar triangles. In case you have forgotten what similar triangles are, we learned that in Sec 2, okay, when we first expose ourselves to congruency and similarity. Similar figures have the same shape but are of different sizes. In fact, they are of proportional sizes. Okay, so in this particular question, I just want to focus on the line MPQ. So I'm just going to extract that out and draw this diagram over here, where I have M, P, and Q being indicated. Okay, so oops, let me get my animation right. Okay, so I have M over here, and then I have my P, oops, okay, P and Q. Alright, so I have also kind of matched, okay, to the x-axis and the y-axis. Sorry that I forgot to label my axis. So I have 2 over here, 6 here, and then 5 here and 2 here. Okay, I still at this point keep in mind that I don't have the coordinates of Q, because I'm kind of like restarting the question, right? Okay, so where are the similar triangles? We will be learning how to prove similar triangles later on this year, okay, in our E-Maths. So I just want us to rely on our impressions of similar figures to recognize that MP to whatever point this may be called, okay, this triangle here is actually similar to this other triangle here. Okay, so this pink one and this green one, they are similar. Okay, trust me for now. All right. So having recognized these similar triangles already, okay, how can we make use of it to solve this question, right? So I'm just going to, for convenience, label this point here as X, and then label this point here as Q. Y I mean. Okay. So like I mentioned, XMP and YPQ are similar triangles. By the way, this entire set is working, so please have the diagram, alright, with the clear indication of X and Y. So this is a claim that I'm making. The XMP and YPQ are similar triangles. Earlier on, I said that similar triangles are proportional. What does that mean? It means that the corresponding sides, MP divided by PQ, will be of the same value as taking MX divided by PS. PY. Sorry, I keep recognizing this as S. It's a 5. Okay, Y is the point. Okay, and then it is also equal in value to XP to SQ. So notice how I have been taking corresponding sides. MP and PQ, they are the diagonal sides. The vertical sides are your MX and PY, sorry, and then our horizontal side, which is XP and YQ. Okay, so the corresponding sides, its ratios are actually equivalent, but as I mentioned earlier, ratio and fractions are kind of equivalent presentations. So I can say MP over PQ equals to MX over PY equals to XP over YQ. Okay, so MP over PQ, that is equals to MX over PY. So what is MP? MP is this thing here, which is actually what we want to find. And PQ is this thing here, which is also what we want to find. So this entire fraction is actually the ratio that we're trying to find. Since I made this claim that they are equal, if I can know the value of this fraction, or if I can know the value of this fraction, it will be the value of this fraction. Okay, which is the essentially the answer for this ratio. So it doesn't matter which one we decide to do. Okay, I have decided to go and find out what is MX and PY. So MX is this vertical line here. PY is this vertical line. So MX is the length, 6 minus 2, that is 4 units. And PY is 2 minus 0, that will be 2 units. So in my calculation, MP over PQ will be equals to 6 minus 2 over 2 minus 0, which simplifies to be 2. Sorry, pardon my sneeze. Okay, so therefore, we see that 2 is actually a whole number, which is 2 over 1, and therefore my ratio will be 2:1. Okay, you may want to take some time to process this, and perhaps also go and recall your concepts of similar triangles, which we learned in Sec 2 last year. That will help you greatly in being able to solve this question. right? So looking at this method that I have presented, it is definitely way shorter than what we have just done earlier on. Okay, however, there's nothing wrong if you have solved the question by making use of the earlier one. As I mentioned to you several times, we must know our content first before we are able to seek for an efficient solution. Okay, so I'll leave you here to go and understand these two methods that I have presented. Don't always try to give us the shortest answer, okay, just to earn the maximum amount of marks. What is really more important is that you're able to think and go through the plan that you have and be confident in whatever that you have written and making sure that it is mathematically sound as well. Alright, so that's all for this lesson. I'll see you again on Friday to continue on this chapter. Bye bye.